Hello guys, welcome to the video. In this video, we'll be discussing diazotization. It's a property of shown by primary amines. So primary amines, they on reaction with what we call as, sorry about that, they on reaction with uh, nitrous acid, that is HNO2. It should be remembered, it's nitrous acid, not nitric acid. They produce what we call as diazonium ion. Fine. Now this diazonium ion, its production is called diazotization. So this diazotization, in case of aromatic, amines, so aryl amines, for example, we have this diazotization. It is NH2. This diazotization, it's of very synthetic importance, because once diazotization is followed, HNO2, once diazotization is done, if it is followed by some other reactions which we will be discussing in future, so we'll be getting N triple bonded N positive charge over here and lone pair over here. So this compound, these aryl compounds which are formed as a result of diazotization, these compounds can be undertaken to different processes by which we can produce different compounds. For example, if we replace this N, it takes away this molecule and it leaves this molecule leaves as N2. Fine. So what we are left with, this molecule here, we can replace, thus we will be replacing this N2 with Cl. So we'll be getting chlorobenzene. We can be replacing it with some other molecule like bromine. So we'll be getting bromobenzene. If we replace it with what we call as iodine, we got iodobenzene. So there are different processes for these two, and for this also we can be replacing it with OH. So we got phenol. Fine. Also we can be replacing it by H as well. Sorry, we can be replacing it by H as well. So replacing it by H, we got back benzene. So these are all synthetic reactions, right? Now these synthetic reactions, they can be used to synthesize them. That's why we study this diazotization in aryl amines. Usually we can do the same thing. For example, we have R and H2 plus HNO2. We will be getting the same thing here as well, that is diazonium ion, R and triple bond N positive charge over here. So this will be again, but this doesn't have any significant importance or synthetic importance. That's why we study diazotization usually for aryl amines. In this video, we'll be also taking we also will be taking we'll be taking the same thing, that we will be taking aryl amines into consideration. Now let's see the mechanistic portion. In the mechanistic portion, the first thing that you got to remember is that this HNO2 in this reaction, it is not added from outside, it's added into the reaction mixture by some other reaction, and that's called in situ. That's called in situ addition. Fine. In situ addition. Now what is in situ addition? Let me show it to you. In situ addition says us that if we have this reaction mixture and we want to add, let's take this example as well, this as example, and we want to add this nitrous acid to this reaction mixture. We won't be directly adding HNO2. Why? Because it is very unstable and we usually don't have this in our labs. So what we do is that we add NaNO2 instead of this. We don't add this, we add instead of that, we'll be adding NaNO2 plus HCl. Fine. Now this Na and this Cl, they will be forming NaCl, and this Na H and this NO2, they will be forming HNO2. So this reactant got produced in the reaction itself. So it's called in situ addition, in situ addition of this reactant, right? Now let's see the mechanistic portion. In the mechanistic portion, first of all, we will be generating this ion from HNO3, from HNO2, that's nitrous acid, this ion, and this will be then acting on our aryl amine. Fine. Now let's see how it is formed. We have H. Sorry about that. So we have NaNO2, Na O negative, O negative. This is positive, O negative, and then we have here. Let me draw the negative sign here. And double bonded to O plus a lone pair on this. When we add HCl to it, it will be giving us this Cl will be forming NaCl with this Na. So we'll be getting NaCl plus H. This H, it will be forming bond with this oxygen. So we'll be getting HO and N double bonded to O. Fine. This is what we have got. A lone pair over here. Right now, this nitrous acid, it's called a nitrous acid. Let me write down the spell for you so that you don't confuse it between nitric acid and nitrous acid. Nitrous. And then let me write it down under this. Nitrous acid. Fine. Now this nitrous acid, it is highly unstable, so that's why it is added in C2. Now this nitrous acid, it will be, it's a very weak acid, so it will be doing the following reaction: HONO. Fine. We got water, H positive and OH negative. This oxygen, it will be given to this. This will leave it, and we will get our molecule of interest, that is N double and lone pair positive charge and O. Now it was the first step, that is generation of this molecule, right? Now what happens is that the second thing that happens is that this aryl amine, it will be reacting with this molecule generated, right? We are taking aniline in our example. You can take any primary amine, and H is here, fine, plus a lone pair over here, plus N, a positive charge, lone pair, and double bonded oxygen. Fine. Now this nitrogen, it will be giving its lone pair to this nitrogen. What we'll get is something like this. We'll be getting something like this. This has N. It has formal bond with another N, which already has a lone pair of electron. It has O, and this nitrogen, it has H and H. Fine. Plus a positive charge because it just donated its electron pair. Now this will be taking this bond pair to form its lone pair, and this H will leave as H positive. Fine. So here we got is something like this. This is the first intermediate of the reaction. It's called N-Nitrosamine. Sorry. This is called N-Nitrosamine. Here N, H, single bonded N and O. Now this is called N-Nitrosamine. Let me write it down here. N-Nitrosamine. This is the first intermediate of the reaction, right? After this, I don't know the spell. This is the only spell I know, so let it be. Now after this nitrosamine and nitrosamine, it will be converted into diazohydroxide, right? Now how will that happen? Let's take a look. So what happens is this N-nitrosamine, let's take it like this, and here we have N, here we have H, here we have H, here we have a lone pair on nitrogen, here we have another N, and here we have O. Fine. Now what would happen? H positive and Cl negative, they are always there. Fine. This oxygen, it will be donating its lone pair to this hydrogen, and what we will get is something like this. And H over here, lone pair on this nitrogen, then N, then double bonded oxygen, then H, and then a positive charge on oxygen. Fine. Now what happens is that this positive charge on oxygen, it is very unstable. So what it would do is that it also has a lone pair of electrons. So it would convert this bond pair into its lone pair, fine. And also this Cl negative, it will be withdrawing this H positive, and this bond pair will also be converted into this bond pair, fine. So what we got is something like this. This is the second intermediate of the reaction that is formed now. This is N double bonded to N, fine, and single bonded OH. Now what is this? This is diazohydroxide, right? This is the second intermediate of the reaction, diazohydroxide. Fine. Now this diazohydroxide, it will be further, giving us the diazonium salt. Now this diazonium hydroxide, what happens in it? Let's take it here. Fine. This diazohydroxide, here you see, here we have N, here we have a lone pair on this nitrogen, here we have double bonded N, and here we have OH, fine. Again, H positive will be coming, plus Cl negative will be coming, sorry about this, plus Cl negative will be coming from the HCl. So it is highly acidic medium that's taken, so that these are always furnished into the reaction mixture, right? Now what happens is that this O, it donates its electron pair again to this H positive, and this gives us something like this. Let me draw it so that you can take note of the bonds formed and the bonds broken after this step, fine. There is, and here is double bond N, here is O positive now, and it has H2 with it, fine. Now again this O positive, it is unstable, so it will be taking this. Also this has a lone pair and this has a lone pair, fine. That should be taken into consideration first. So this O positive, it will be taking this bond pair into its lone pair, releasing as water, right? After it releasing as water, we'll be having this nitrogen giving its lone pair bond to form a bond between these two nitrogens. So what we will get is something like this. Sorry for the shapes that are going on. I don't know why I'm not able to draw them right away, but still let's keep trying. So all right, here we got the shape. So here we have N. Now this lone pair, it has converted to double bond, it has converted to triple bond between these two nitrogens, and a positive charge has already developed on it, and a lone pair is already on it. Now this Cl negative from this H, it will be there to stabilize this. So what we have got is something like this, and this is called diazonium ion. Let me write it down for here, diazonium ion, right? Now this diazonium ion, as I told you, it has synthetic properties for aromatic compounds. So it will be giving us sometimes phenol with some reaction. Then we'll be seeing there are Sadmier reaction and Gatterman reaction, which give us chloro and bromobenzene, right? Now those are different tasks now and they are not a part of this lecture, but you have now noted that how diazonium ions are formed, and this is in general diazotization. So let me recapitulate the whole thing for you. In diazotization, the first thing that we keep in mind is that we add HNO2 not from outside but from inside. That is, it gets produced inside the reaction mixture by different reaction, and this addition is called in situ addition, fine. It is done by addition of NaNO2 and HCl, fine. After that, when HNO2 is produced, that is nitrous acid is produced, that nitrous acid that gives us this molecule, which is then attacking this arylamine. Now then arylamine attacks this molecule NO nitroso molecule, right? So this nitroso molecule, it will be now nitroso ion, it will be now given this electron pair, and it will be forming N-Nitrosamine, fine. In the first step, this is the first intermediate of the reaction. After this N-Nitrosamine, it is taken, HCl acts on it, and it gives us diazohydroxide, right? This is diazohydroxide. After that, diazohydroxide, again HCl works on it, and what we get is something like this, that is diazonium ion. Now, as I told you, these diazonium ions, they are of synthetic importance for aromatic compounds, and that's all about diazotization. Make sure to subscribe to the channel Chemistry Crux in order to get more videos like this.